So now that you guys are on your final projects or big projects and you're working in MonoGame, some students have requested a full game kind of demo. Um, it's very last minute, so I did the best I could. I wrote this code very, very quickly. So hopefully it gives you what you want and what you need. I've shown demos of this in the past that are similar, but this code was written last night in a couple hours between last night and this morning. So there may be a few bugs, so please let me know if you see any of them. And I do plan on tweaking this and updating it if I have time. There's a few major components in there that I would really like to put in there. I just didn't simply have time to do so to get it up and ready for everybody in time. So the big component is I wanted to put an instructions page on there, and I just didn't have a chance to. And the second one is sound. I really, really want to get sound in here. Again, that involves me finding the sounds, editing the sounds, and making sure that they're playing at the right time, as well as explosions. So when things are destroyed. So those are the major things that I'd like to put in here, and I will when I get a chance. But for now, this covers the basics, and the reason why I chose to do this one is because it literally covers every concept that we learned in the grade 11 course. Now, I mean the actual course content. There's no grade 12 concepts in here because I wanted the code itself approachable by everybody at every level of the school. But the grade 12s will still benefit from it because they can see how the gaming concepts are applied to everything within the actual structure in terms of like the logic and everything like that. So in lieu of having no instructions page, I've put how to actually play the game and everything like that right inside of the description at the top. This is going to be a quick video in terms of showing you how everything works and my thought process behind starting. But let me start off by demoing the program. Hopefully it runs smoothly. This capturing software only captures at a certain frame rate. I think it's 30 frames per second, but the game runs at 60. So basic menu tells me the current high score of the game, title of the game, and some menu options that I've set up to highlight when I hover over them. Not when I click, just when I hover over. If I click exit, it will exit the game. You notice in the background that there is an animated background. That's actually 3 separate images. There's one image that's not moving at the very back. There's an image in the middle that's moving at a fairly slow rate, and then there's an image at the front that's moving at a faster rate. And the idea is to give us the illusion of depth, where the things that are moving faster are a little closer to us because that's how it works. So the idea of doing these kind of layered scrolling screens is something called parallax. It's very common in side-scrolling games and whatnot to give the illusion of depth. And sometimes the player will be somewhere in between those layers to actually give you even more illusion of depth because it'll feel like something is in front of the player. So very common technique. I'm using it on literally every game state so you can see it everywhere. So when I go into play, I control the little ship. I can control them with WASD or the arrows. I can shoot with my left mouse button, and it shoots little animated bullets. And every time I hit one of the big balls, it gets shrunk down into a small ball, moves faster, changes its color. Now, I get points. I get 50 points for every big ball that I shoot, and 100 points for every small ball that I shoot. If a ball collides with the left side of the screen or leaves the left side of the screen, that means that I missed it. So I actually lose 50 points for that. If I get hit by one of the balls, I take damage. The big ball does 2 damage and the small ball does 1 damage. So I lost here because I lost all my health. It says, loser is you. But I did get a new high score of 850 points. So if I go back in to the menu, you can see that the high score has been updated to 850. If I start again, everything has been reset, health score and everything like that. Oops. Let's see if I can. Now, what you'll notice is after I kill a certain number of enemies, the star starts to pop. Now, when I say kill, that means kill the little guys. Now, the way to end a level by choice is to right-click on that star. Now, when you do that is up to you. So loser is you this time because I didn't beat the high score. Go back in again. I have it set to, I purposely set it low to the kill count required to get to the star, just so I can show you. But the way that we get this is you have to right click on the star. And when you right click on the star, that will end the game manually. And that means you won the level. So you finished on your own choices. Now that being said, it's a choice of when you do that because gameplay-wise, because if you ended early and you haven't beat the high score, well, what's the point, right? So that's pretty much the entire game. And normally I would slide the instructions page right in there. Sound and everything will be coming right now. Music, background music, sound effects when I click on things, even maybe when I hover over certain things. Sound effects for each missile that I shoot, that kind of stuff. The player is limited in how many missiles they can shoot. They can only have 5 active missiles at once. So if I try and click, it just simply won't shoot anymore. The spawning of the enemies is randomized, meaning every I have a certain random time criteria. I think it's between 500 milliseconds and 1500 milliseconds or something like that. The next enemy will spawn. Now, I'm basically recycling bullets. I'm recycling enemies and everything like that. And basically what that means is when an enemy or a bullet is destroyed or leaves the screen, it gets stored in an inactive location, somewhere up here. And every time I need to get a new one, I look for any of those things that are stored up there because those are considered inactive. And to activate it, I simply move it onto the screen. So anything that's not at that inactive location, I consider as active. Meaning I will update it, which means I will move it, I will draw it, I will do collisions with it, but I only do that with things that are active. Anything else is just ignored. I think that is the gist of things. You'll notice that when the score decreases, it won't go below 50, so there's certain things in there. Again, I might have some bugs in here somewhere because I wrote this stuff so fast, but I think for the most part, it is okay. All right, so let's go look at the code to see what happened and what my process was. So looking at this game, the first thing that I did was I built the menu. So I said, okay, well, how do I want to do this menu? This menu has 0 images other than the scrolling background. 0. Everything is text-based. The rectangles are using the helper library to draw semi-transparent rectangles on there. I'm checking collision, but not clicking. Every time I go over one of these boxes, I draw it with a different color as opposed to its standard green color. The text on top, I'm literally just drawing the text twice. Once for a white background, like a white drop shadow, and then again for whatever color it is I want to draw text. So that's just to emphasize it a little bit. Right? So the first thing I did was I added my boxes, I added my text and everything like that. Then I set up my collision detection for those 2 boxes. Oh, I did forget to mention that there is a pause state as well. I guess I totally missed that one. Yeah, it's P to pause. So after the menu, I started looking at the gameplay itself, and I started adding the elements in order of importance. So the first thing I did was I added my player, and I got the player to move. Okay? Once I got the player to move, I started adding bullets and figuring out how I could store the bullets, move the bullets, recycle the bullets, and animate the bullets, because they're animations. They're not just images. So once I was done with the player, then I started adding the enemies. So the enemies are game circles. They're not images. They're game circles. So again, I'm using that helper library to do this. And the game circles are spawned, as I said, at those random intervals. I should probably spread apart those time intervals because it looks like they're spawning a little close together. What else? Yeah, so the enemies, they're spawning. They're all moving at specific speeds and have specific colors based on their size. I could randomize those as well if I want to, but that would mean I would have to track individual speeds for every single enemy. And maybe that is what I want to do. I don't know. So once I got the enemies up and running, I started doing collision between things. So I started doing collision between the bullet and the right side of the screen. I started doing collision between the enemies and the left side of the screen. Then I did collision between the enemies and the player to determine whether I take health damage. Then I did collision between the player's bullets and the enemies. That was the biggest chunk because for every single bullet on the screen, you have to compare it against every single circle on the screen. So it's a loop within a loop to make that happen. So you loop through all your bullets, and then inside of that, you loop through all of your enemies. Now, again, you only care about the inactive ones. You only care about the active ones. So you have an if statement in there that says, hey, if this guy's active, check its collision. Otherwise, it moves on to the next element of the array. So once I got collision with those things working, that's the bulk of the game. Then I started fleshing it out, so I started adding the score and the health in there. So every time I destroyed something, or every time an enemy leaves the screen, I started adding or removing score. Anytime that the player gets hit by one of the balls, I started reducing the score. When the game is over, when I detected the game is over, such as me right-clicking on the star, that is where I would compare the player's score to the high score. If theirs is better, strictly better, then I set the high score equal to the new high score, and I inform the user in the end game that, hey, you achieved a high score. But that message only shows up if their score is actually better, and that's simply done with a Boolean variable. I just say, okay, I set a new high score, and then in my draw code for my end of game, I say, if that Boolean is true, draw this message. Now, there's user input on every screen, every game state. So like the end of game, the menu, the pause, things like this. So the only thing that this game state is looking for is me hitting the P key. If I hit any other key right now, it does nothing. If I shoot, it does nothing. The spawn timer's not working. Nothing's working. It's just paused. Now, if I come back in here, and at the end of the game, now I'm on this screen, the only input that's detected is the enter key. And when I hit that enter key, a number of things happen. First of all, it's going to take me back to the menu state. But second of all, I called a method I created called reset game. And that basically resets all of my vital things back to their original values. So score gets set back to 0. I deactivate all of my enemies. I deactivate all of my bullets. I reset the star to being inactive. I reset all the timers and everything like that. Everything is reset inside of that reset game method. And that is called when I leave the game over screen to go back to the menu screen. So it's not called in the menu screen. It's called at the end of the game over screen. So it only happens once, right? Scoring health, and then I started setting up all those extra screens that I mentioned. So the pause screen, the game over screen, and just text to display on those various screens. I used a lot of sub-programs so I could reduce the work. This program is fully documented and probably overly documented. I would say it probably follows the rule that about 30% of the code is comments, which would mean I think it's just over 1,000 lines or something. It's 1,070 lines. So I would say that it's probably 700 lines of actual code. Clean, well-spaced out code. It could be shrunk down if I want to, but I don't want that. I'd rather have good, clean code. So about 700 lines, and then the rest of it is documentation. So let's take a quick look and figure all this stuff out. So I have a whole bunch of constants to represent things like my game states, what my maximum number of bullets and enemies are, what the minimum spawn time. So this is actually another thing that I wanted to do as well that I didn't end up doing is after a certain period of time, reducing that spawn range. So in the very beginning, that spawn range is, where did I put that? I gotta find it. Between 1 second and 1.5 seconds. So it's very tight. What I would do with that is after so many enemies are killed or whatnot, or after so much time has passed, I would reduce both those ranges. So from 1 to 1.5 seconds, I might reduce that down to 800 milliseconds to 1200 milliseconds, things like that. But eventually, it's going to get to a point where I don't want it to reduce anymore. That should actually probably be... No, that's not the right one. Where'd it go? Here it is. Min spawn time. I don't want to reduce it past that point because things will just get too fast and it'll be unplayable at that point. These just represent certain constants for my enemies, such as how big they are and how fast they move based on their size. Our kill targets, how many kills I want to get before the star starts showing up. We're gonna call that the shooting star. I'm going to change this to 10. That's what I actually wanted it to be in the very beginning. This is a constant that represents a scenario where I'm trying to activate either a bullet or a enemy, and there isn't one to activate. Because remember, we're recycling. So basically, I've created a method that will loop through all of the bullets and say, find me the first one that is at the inactive position. Okay? If I don't find one, that means that there's nothing available for me to activate. So instead of returning the index of the one I want to activate, I return a -1, which is this constant no object. That tells me as a programmer that I couldn't find anything, so don't activate anything. Don't waste the time or the effort. Basic user interface stuff, textures and everything like that. I've tried to organize it in terms of how I will be using it. So this is all the stuff related to the menu. Down here we have all the game-related stuff, the player data, the movement data, the health and scoring data, kill count, star data, the heads-up display text, both the messages as well as the text. Bullet information, so you can see I'm storing the bullets. I load in the bullet image once, which is it's right here. It's just a regular sprite sheet. I've created an array of animations. So for every bullet, it has its own animation because each bullet may be animating at a different time. And that's fine. And then I've created an array of vector 2 of the same size to maintain each bullet's true position so I can move it at any speed I wanted to. And now this basically is how fast the bullets move in 1 second. So this is the max speed, how they will move 400 pixels in 1 second. So it's pretty quick. The player moves at 300 pixels for 1 second. Here are my enemies. So you can see it's just an array of game circles. Again, that's part of the helper class. Timer, how often it's going to spawn these things. Again, that's part of the helper class. And colors that represent what color each size is. Now, I don't have these as constants for a few reasons, mainly because you can't do that for these types of objects. But I may want to change it for some reason. Well, I don't know what, but maybe. I don't know. And then we have our minimum and maximum spawn time. So that's all the variables we need. Pardon me. Going down, I've stored my screen width and height, and I made my mouse visible. I didn't change my screen resolution, so by default, it's still at 800 by 480. Didn't really need to change anything. It's all good. Down here, I'm setting up loading everything in, loading in my fonts that I've set up, background images. So this is all background stuff for that scrolling background. Okay, so I have the regular static image that doesn't move, and then I have I've accidentally put something in the wrong spot. There we go. This is the rest of my scrolling background stuff. This should not be here. All of this stuff should be right up here. I think I just got overexcited moving things around. We should be putting this right there. So this loads in our scrolling images, and this sets up their locations. So one is on the screen, one is off the screen for both layers. And then after that, I load in my star data, my bullets. So this is me setting up the bullets. So I load in the image once, and then I loop through, and I create every single animation for every index of the bullets animation array. They all have the exact same data. Nothing changes. And then I stored their true positions to match where they're located at this point. And then I do the same thing for the enemies for the most part, except they're not animations, they're game circles. For every game circle, I create a new game circle. I put it at the inactive position to start, and they all start with the big radius. I think I changed that. That doesn't need to be there anymore. And then our spawn timer, you can see the spawn timer, I've set it up to be a random time between the minimum and the maximum spawn time. It's not activated yet because I don't want it to start counting until I actually go into the gameplay. Because remember, we start in the menu state. So when I go from menu to gameplay, I will turn that spawn timer on. So our setup player data, this is just basically setting up the image, its location and its true position. I've centered it. You'll see me doing a lot of math like this to make things go in good relative positions. So half the screen height minus half the height of the player will put me exactly at the center of the screen vertically. Things like that. You can see I do that all over the place. I'm using this method called measure string so I can figure out how wide and how tall my output for my strings are going to be so I can center them. Say, for example, center them in those buttons, center them on the screen and things like that. And this is just more text locations doing the same stuff. Now, that was load content. You'll see that my update and my draw are very small. Update updates all the input stuff, and then calls a switch statement to call separate methods for every single game state that I have. Menu, gameplay, pause, and game over. The only one that has a parameter is update gameplay because it needs the game time for things like timers and animation and stuff like that. Draw, same thing, except it doesn't have any input to update. It just says, inside of the sprite batch, draw the various game states. That's it, whatever one is active. Nothing else to change there. So then I just go through and I implement each one of those methods one at a time. So update menu, I call my scrolling screen, so I want to have that scrolling screen on every single game state. And then the only thing I'm checking inside a menu is a left click of one of my two buttons. Did they click my play button or my exit button? If they hit my play button, I change the game state and I activate that timer. Then it's immediately going to go into gameplay. So here's update gameplay. This is the bulk of the entire program. It starts at about line 400, and it ends. Where is it? Right here at 700. So it's like 325 lines. So if this was, that's easily a third of the program is update gameplay, which is fairly reasonable. So for every section here, just to keep things clean for everybody to read, I have added big kind of header sections for each chunk of code that I'm doing in here. So for this first chunk, I'm handling user input, pause, directional movement, left clicking. I don't actually do the right clicking here because that happens when I'm doing collision detection between the mouse and the an extra bracket there. The mouse and the I do want that. The mouse and the star. There we go. So that's going to happen in collision detection. But everything else is done right here. So there's the pause key. Here's the vertical movement. Here's the horizontal movement. Here's me updating the position because I just modified the speed here. And then down here, this is where we're getting input for shooting. So if they get the left button, and it's a new left button, the first thing I'm going to do is I'm going to find the first inactive object. I'm going to find the first inactive bullet. Now, what does that mean? It means that I'm going to search through all of my bullets, and I'm looking for the first one in the array that is currently located at the inactive position, which I set at, I think I set it at like negative 200x and 200y. So it's, it's 200x, negative 200y. So it's off the screen, basically. And if it's off the screen, I am not drawing it, I am not moving it, I am not doing collision with it, I'm not doing anything with it. So if it finds an index, that means it'll have a valid index of 0 or greater. So I'm going to activate it. And the only thing I need to activate it is not have it at the inactive position. Because the only thing that's inactive is the stuff that's currently stored there. I can get rid of that now. Okay. So to move it, I move its destination rectangle, because remember, these are animations. I move the animation's destination rectangle to the right side of the ship, centered directly in the center of the ship, and I set its true position to that new position. And that's how we activate a bullet. Enemy spawning, first thing I do is I update the spawn timer. If that spawn timer is now finished, it means it's all done. I'm going to regenerate a new spawn time, and then I'm going to do the same thing I did for the bullet. I'm going to find the first inactive enemy by searching through to find the first one that is at the inactive position. And if I find one, I'm going to activate it. And that just means I need to move it onto the screen. Or move it I shouldn't say that. I should say I just need to move it away from the inactive position. In this case, I'm putting it somewhere directly on the right-hand side of the screen at a random height between the top and the bottom of the screen. And then it just starts moving automatically. I don't have to do anything there. So I've spawned it. It's ready to go. So that's enemy spawning. Next up is updating all the game elements. So there's the scrolling screen. Next is I need to update my bullets, enemy, and the star. But you'll notice I'm only updating the active ones. So how do I do that? For each one of those collections, I'm going to loop. I'm going to loop through all my bullets. Okay? If it is not inactive, which that means it's active. So if it's not inactive, it's active. I want to move the bullet, and then I want to update its animation because it's an animated object. Nothing else there. Now I want to update all my enemies. The exact same thing. Loop through all the enemies. If it's not inactive, I'm going to move it based on its size. So if it's a big ball, then I'm going to move it by the big speed. Otherwise, I'm going to move it by the small speed. Now, these are game circles. That's why I can use this translate method, because translate is a method directly attached to game circles. Translate just means how far are you moving in the X and Y direction. What about the star? Because I don't have a collection of stars. I just have a single star. So I'm just going to check it. If the star is not inactive, well, I'm going to move the star up because it's moving up the screen, change its true position, and then change its draw position. And it's animated as well. So I need to update its animation frame. So that's all my updating. Collision detection is the meat of this entire thing. So I have separate collision detections for each piece. So the player wall collision keeps the player within the boundaries of the screen. So I'm just checking the left, the right, the top, and the bottom walls. And if I need to adjust and force the player back on the screen, this is where I do that. And then if I did that, I also set its draw position as well. Now the bullet versus the wall and the enemy. Again, I only care about active bullets. So I loop through my bullets. If the current bullet I'm looking at is not inactive, then I'm going to do something with it. I'm going to check to see if it hit the wall. Remember, bullets are moving to the right, so I'm checking to see whether it passed the screen width. If it did, I'm just going to deactivate the bullet. All that does is put it into the inactive position. Nothing else. But if it didn't hit the wall, I want to check to see if it hit one of the enemies. So, inside of here, I'm looping through all of my enemies now. This is a J loop. Now I'm looping through every single one of my enemies. But again, I only care about the active enemies. So if the current enemy is not inactive, it means it's active, then I'm going to check its intersection between the current bullet and the current enemy. If they collide, so if my bullet just hit an enemy, I'm going to deactivate the bullet because it's done. But now I'm going to deal with the enemy a little different, because if the enemy is a big ball, then I need to shrink it down into a small ball and award the points for hitting a big ball. But if it's a small ball, then I'm going to deactivate the enemy because I just killed it. I'm going to increase my kill counter, and I'm going to adjust my score for hitting a small ball. Down here, this is where I activate the star. So if I just got a kill, I want to check to see whether the kills have exceeded the kill target. That should be greater than or equal to, actually. Greater than or equal to the kill target, and it's not already active. I don't want to activate it if it's already active. That would be silly. Right? So randomized star position, it does something interesting. It takes the screen and it puts the star below the screen, so somewhere below screen height. So screen height and another half of the screen height. All right, so the screen height right now is 480. That means it's going to put it in between 480 and 600. 600? 700. No, that's not even close. 720. Yeah, between 480 and 720. So that's vertically where it's going to go. Horizontally, it's going to go on the right side of the screen. Okay. So that is all of our collision detection. So now that we've handled all those various forms of collision detection, what we're doing now is we need to... Oh, we still missed a couple. Sorry, my mistake. Now we have to check against the enemy and the left wall. So if the balls flew off the screen to the left... Well, I got to punish the player because they missed that ball, right? But again, I'm only looking at the active ones. If they have left the... If their right-hand side has passed 0, so they've completely left the screen on the left-hand side of the screen, I'm going to deactivate that enemy, and I'm going to subtract 50 points from their score, which is what the value of missed enemy points is. Now we have to check the enemy versus the player, so the ball hitting the actual player. What that basically means is, again, we're looking at all of the enemies, but again, only the active ones. If the current enemy collides with the player's rectangle, then we're going to deactivate the enemy because it gets destroyed. The ball gets destroyed. and the player loses health based on its size. So if it's a big ball, we lose 2 health. If it's a small ball, then we lose 1 health. I suppose I could change this just to minus equals 2. There we go. That's a little bit easier. And then the star may get, because the star is moving vertically, right? So every time the star leaves the screen, that means I missed clicking it. I'm not punishing the player. It just means they just didn't get to end the level yet. So basically what we're doing here is we're saying if the star is active, then what we want to do is check to see whether it left the top of the screen. So if the bottom of the star is above 0, then we're going to re-randomize its position below the screen on the right-hand half of the screen, somewhere along those lines. Now this is checking to see whether we right-clicked on the star. So if our kills are greater than the kill target, so we can actually click on the star, and we get a right mouse button click, and that mouse position is over top of the star, then we're ending the game. Winner is you. We check to see whether they got a new high score. If they did, we award that score, and we set the fact that they set a new high score to true. I also am adjusting some of my text output because I just changed this message from something else. So I want to center it on the screen. So that's what this does. I'm changing its X position to be centered on the screen. And now the game's over. So I set the game state to game over. That is the last of the collision detection. The last thing that happens is update is checking for a loss. So if health went below 0 because the player took another hit, then we check, sorry, loser is you. We check for the high score again. It's still possible to get a high score even if you lose. That's okay. Most games are like that. We adjust the message location again because we changed the message, and we change the game state to game over. So that's the entire update, and that's the biggest part of the whole thing and probably the most challenging. The rest of the stuff is all support for that for the most part. I'll go over that. Yeah, I guess I'll go over all of that. I'll try and do it quickly, though. You might want to fast forward through some of that, though. Okay, so the next piece of the puzzle is going through the other updates and the draws. So update pause doesn't do much. It just looks for the P key to bring the gameplay bring the state back to gameplay. Update game over does something similar. It waits for the enter key. When we get the enter key, it resets the game and then sets the game state back to menu. You notice that they're all calling scroll screen, though. Now we get into the draw methods. So for draw menu, draw the background, which is the scrolling screen. I draw the title of the screen. I draw all the menu buttons. So this is their rectangles, and then followed that by the text for those buttons. And then I draw the high score at the top of the screen so the player can always see it while they're sitting in that menu. And then we get into the drawing the gameplay. This is obviously the biggest and most important one. We draw the background. I draw all the HUD related stuff. I like to draw the HUD behind the players and everything like that, so that way the players can kind of go over top of it and they're not obscured. But that's a personal choice. And then I'm drawing the player itself. I'm drawing all the bullets, but only the active ones. So if they're not inactive, they're active, so we draw them. Do the same thing for the enemies, only the active ones. But this time, depending on their size, I use a different color, big color or small color. And then the star, if the star is active, so not inactive, I draw the star. So that's the entire game drawing. Drawing pause is really, really short. Just draw the background and then draw the message that says, hey, you're paused. And this is how you get out of pause. Similarly speaking for game over, background. We draw the score on the screen so the player can see what the score was that they achieved. And we draw the title saying that this is the whether you won or you lost. And here, if they achieved a new high score, I draw the new high score message. And then finally, how the heck do you get out of that message? How do you get out of that window as well? Draw background, that is just drawing the animated background. You can see I draw the still background first. And then I draw the 4 animated the 4 scrolling images, 2 for each layer. Draw text is that method that I told you about that would draw the text and then draw the white drop shadow or whatever color drop shadow you want. Typically, I use white. Reset game. Some people might be interested in this. This is a lot of people put more thought into this than really is needed. Just basically go through your code and say, what do I need to reset and set back to its original values before I can start another gameplay, right? So here's me resetting the score, the kill counter, the health counter, turning off the new high score thing so it gets reset for the next time, adjusting the player position back to where it started, recalculating a new spawn timer, deactivating all the bullets, deactivating all the enemies, deactivating the star. And that's it. Scroll screen is a little bit uglier than what we normally see for scrolling screens, and that's because I'm doing multiple layers, right? Normally we would just kind of move the thing across the screen. If it reaches the edge, then we move it back. I'm still doing that same thing, but because I'm doing it with, I have to do it multiple times because there's more than one layer, but it's still doing the exact same thing. So here's those methods that find those first inactive items. I loop through, so I pass, in this first one, I'm passing in an array of vector 2s, and I'm looping through each one. And I'm looking for the first inactive one. So if it's inactive, I'm going to return its index. But if I got through the entire loop and didn't find one, so I never returned, that means I'm going to return that no object variable, which is a -1, an impossible index. Now, if you remember my code from above, when that occurred, I checked to see that the return value was greater than or equal to 0. Well, since this is returning -1, it won't go into that code and it won't spawn enemies or bullets or anything like that. Find inactive enemy does the exact same thing, but because it doesn't work with vector 2s, it works with game circles. I had to rewrite it and modify it a little bit. And these are just the deactivate methods. Deactivate a bullet just puts it off the screen to the inactive position. Deactivating an enemy does the exact same thing, but also resets its radius back to a big circle. Deactivating the star just repositions it back to the inactive position. And randomized star position is the one that I told you that randomized it below and to the right side of the screen. And this is the method that checks to see whether something is inactive. If its X position is the inactive X position and its Y position is the inactive position, then it is inactive. So that would return a true. If it failed either one of those things, that's a false. So that would mean it was not inactive. So that's the entire program from start to finish. I know it's a little meaty, but there's a lot going on, and that's what you guys were asking for. You're asking for a complete setup. Again, this is missing a couple parts that I would like to put in there, sound, instructions, and things like that. But outside of that, it's pretty much complete, and there's not a whole lot left to do. So with that in mind, good luck and have fun.